Alright, hey everyone, welcome to the third part of our interactive objects tutorial in our larger first-person narrative game tutorial. Where we left off, we were encountering a little bit of a problem wherein we need to figure out how to have a couple of different scripts communicate without being so tightly coupled. So specifically, we went and made this property looked at interactive, and we made it public, and we need a way for this script in our interact with looked at to know about whatever the player is looking at, which the detect looked at interactive script is doing, without necessarily having such a specific reference to that other script. All right, and I'm going to quickly introduce another scenario where this is also going to be an issue, so it'll really be obvious. All right, so before we get started solving that problem, I'm going to introduce a related problem. So right now in our game, when you look at interactive objects, our detect interactive objects script is actually aware of what you're looking at, and you can click on it and you can see in the console it's actually doing stuff, just not very exciting stuff. Well, we need to make it way more obvious to the player that they're looking at an interactive object, right? Right now you would just be pixel hunting, clicking everything you possibly could see in order to see if anything does anything. Let's work on adding a little bit better feedback for our player when they're looking at an interactive object. So I'm going to do that with UI text. So when the player looks at an interactive object, we're going to show some UI text. In fact, I think, yeah, look, here's our game design doc for this feature, and so we can build it according to these specifications. When looking at nearby interactive object, UI display text calls out the object or describes the possible interaction with it. Each interactive object can have its own custom text. When not looking at an interactive object, the text is hidden. So here's some examples. I think examples are pretty useful if you're writing a design doc. It just helps, you know, if I don't want to read all this or this is confusing, if I look at the example, that kind of drives it home, right? So as a designer, it's good to think about examples or even pictures, fake screenshots, like mock screenshots are really useful also. Okay, so this is our feature we're going to do, this display text. So let's head to Unity. Let's implement this as far as we can get before we run into the same problem we were just describing. I'm going to right-click on my canvas so that whatever I'm about to add comes in as a child of the canvas. And I'm going to add a UI text. And let's see where this guy came in. So text, UI text is like a 2D thing, right? So we're going to go to this 2D mode to look at it. And the text is somewhere in here. I'm going to select it here. I just double click it and you can see where it went. And I'm going to zoom out and kind of figure out where it is in the larger context of my canvas, which my canvas is mapped to the player's monitor or TV screen, right? So if this is their TV screen, this is where my text is going to show up. And I'm going to turn the grid off because it's really just making things hard to see. Alright, so there we go. What do we want this text to say? Well, for now, let's just make it say something like interactive object display text. Okay. We want to... So obviously we'll be updating what this says in code, but this is good for now so that when we're just looking at it in a glance in our scene, we understand what this text is for. Let's go ahead and rename it before we forget. We will call it interactive object display text. Sounds good. Or maybe we could even call it looked at interactive display text. I don't know, something that makes sense to you. And now we need to make sure that this is actually legible. If we click on the game window, you'll see a good example of what your UI actually looks like when you're playing the game. Just to prove it to you, I can run the game and it should look just like this, right? So this is what we got so far. I think we need to do a couple of formatting tweaks to make this better. So first of all, I'm going to kind of use the same technique I did on the reticle to make sure it always shows up even though I may scale it larger than this text box. So for example, if I start bumping up the font, eventually it will just disappear unless it gets too big to fit in there. So what I will do is, you could just make this text box larger or map it to the whole screen, which isn't a horrible idea, but for now what I'm going to do is just choose overflow, and overflow for vertical as well. I want to center this text paragraph alignment, and I want it to be in the middle vertical alignment. And now it should start to show up no matter what, right? So now if you look carefully at this is our game window. You can see it's overlapping with our targeting reticle, and that's bad. We want this text to be visible without blocking or obscuring the targeting reticle, so we need to sort of move it up. What I'm going to do, first of all, let's just make sure this is centered. So I've got my interactive object display text selected here. You can see I'm going to click on the anchors. It's anchored to the center, but let's just make sure it's positioned in the center. So hold Alt and then click there. Alright, so it is centered. That's good. Since I know it's centered, I'm going to bump it up a little bit so that it's not obscuring my tiny little targeting reticle there. The way I'm going to do that is find the position Y here with the interactive object display text selected, and I'm going to just click and drag right where you'll see your mouse cursor starts to get these left and right arrows. That means you can click and drag there, and I find that as a useful way because I don't know exactly how far I want to move it. So I'm just going to click and drag, and you can see you can move the mouse all the way across the screen and it just loops, so you can just keep going in the same direction until you get it about, I don't know, like right about here, right? That looks good to me. Now I'm going to use the same coloring scheme I had on my targeting reticule, so I'm going to make this font white. So I'll choose the color option here and let's make it white. You can see that's pretty tough to read when you have a light colored background, so we will also use the outline component that we used for our targeting reticule as well. So let's go ahead and add that. By default it's a black outline. This is maybe a little big. I don't know. Maybe it's not. I don't know. You can play with it and get it how you like. And obviously if you want to add your own fonts to make this more customized, you just need to go to your assets folder, create a new folder for fonts, and then just drag in whatever fonts you want to use. And then when you have a UI text selected here, you can choose whatever other font you've added to your project. So that's pretty simple. I'm just going to go with the default to keep things moving. Alright, so let's just play the game and just double check this seems like a reasonable position and scale for this text. Remember, the text is going to tell us about what we're looking at. So if I'm looking at nothing, it won't say anything. It'll be hidden, more or less. And when I look at a thing that's interactive, it'll tell me it'll describe what that thing is. Boy, I don't understand that shaking. That's interesting. Anyway, it'll describe what that thing is, or it'll describe the nature of the interaction I can have with it. So for instance, if it was a door, it could say open. If it's a switch, it could say turn on lights or something like that. Or it could just say light switch, and you click it and it does whatever. It's up to you as a designer, but you have that kind of flexibility. Alright, so that's positioned and formatted in a way that I'm happy with. So this was all positioned how we like. The next step will be to create a script for it. So let's go into our scripts folder here, right click, and create a new script. Ooh, there it is. Alright, so we want to name our script what it is for, or what it's going to do. This script is basically going to define all the functionality for the interactive display text. So let's just call this thing very specifically looked at interactive display text. Sounds good. No question about what that's for, hopefully. We will go ahead and, maybe I should rename this to be more related to how I named this. So let's just call this also looked at interactive display text. Cool. All right, let's put this script on the text before I forget. And so basically the pattern is we make a thing, we create a script that's named after the thing, and then put that script on it, and then insert into the script the functionality we want for that particular game object. All right, so what do we want this to do? It needs to know about what we're looking at, and then change the text to match. So I don't know, let's just delete the start and update for now so it's out of my way, and I'm just going to think about what are the objects that this needs right off the bat. It needs to know the currently looked at iInteractive, so let's make a variable. We'll say private iInteractive looked at object. All right, so this is the thing we're looking at, and we can actually, let's name this a little better. Let's call this looked at interactive, because it's literally it's an iInteractive that we're looking at. Okay, and then we need to know about that. We also need to know about the text component that we're trying to change. So private text, this is of the type text. If you were to go into the Unity editor, you could look and click on this sucker. You can see it has a text component, so we need a variable for that, which will allow us to change this. So I typed in text, but it's underlined in red. It says we don't know about a thing called text. The reason is we need a using statement. You could either just manually type it in, or if you have Visual Studio and you have your cursor over this and hit Control period, it will say you can just choose the quick action to use unityengine.ui. So go ahead and add that in. Or if you don't, if you're on Mac and it's a different hotkey or you're using a different text editor, just type that in. Alright, so now you can see text is color coded. It understands what a text is because we used that extra using statement. What do we want to call this thing? Let's just call it display text. That's pretty self-evident. Alright, cool. So these are the two things we need to know about. Also, before we go too much further, let's not forget to add our summary. So 3 forward slashes in Visual Studio gives you the summary, and we'll just say this UI text displays info about the currently looked at interactive element. We could even say iInteractive if you wanted. The text should be hidden if the player is not currently looking at it or at an interactive. There we go. So that's what this thing is going to do. I think we should make a function that basically updates the text, right? So let's say private void update display text, and what we'll do is basically we just need to change the text property of this display text to something new. So we'll say display text.text equals, all right, what should it equal? Well, what we have been doing is saying looked at interactive dot name. We were looking at the name of the thing basically, but I don't think that's good enough. Also, interestingly, we only know this is an iInteractive, so we actually don't know that it's for sure a game object. So we can't even access its .gameObject.name necessarily. So what I'm thinking is we need to be assured that every interactive has some sort of display text. So that means we need to go back to our interface, and we already are guaranteeing every iInteractive has an interact with function, but we want to make sure that they all also have a display text. Now you can't add fields to a property, or I'm sorry, you can't add fields to an interface. So you can't say something like string display text because you can't add fields in an interface. But remember, we know about properties, and because everything in an interface needs to be public, we want to use properties anyway. Remember, we have our little guide that says use properties instead of public variables. So since this has to be a public thing anyway, basically C# is sort of enforcing that we use properties here. So the syntax for properties, first of all, it's still going to be a string, but we're going to use a capital letter, so Pascal case, and we have to define a getter and a setter here, right? Or you don't have to literally define it, but you need to list that it's a thing, right? We can, when we go to use, when we implement this interface in whatever class, like here, we will have to define exactly what happens in the get and set for these things if we want something fancy to happen. But I'm going to hold up right here and think about this for a minute. So the getter is what gets called when you try to access this information. And the set is what gets called when you try to set a new value to this information. And my thought is that we don't necessarily need to be guaranteed that every iInteractive has a public set for its display text. I don't necessarily want every other class out there to be able to set the display text of interactives. I think, at least initially, the interactives themselves should be in charge of just knowing what their display text is. So in other words, I don't want a public setter for this. I want it to sort of be read only. So all other classes can do is get the value of the display text. So let's just leave it like this for the time being. All right, so now that I've added a display text property to our iInteractive, if we flip back to this interactive object, which is implementing that interface, you'll see it's underlined in red. The reason it's underlined in red is that we're no longer implementing all of the required things for that interface. So that's what this error message is kind of telling us. It says it does not implement interface member interactive.displayText, because we have to be assured that every iInteractive has two things now. It has an interact with function and a display text property. So remember, if you actually move the cursor and select this iInteractive that's underlined in red in Visual Studio and PC and hit Control period, you have the quick action to implement this interface. So you could do something like that, and it stubs in with a syntax you've probably never seen before. And for better or worse, there are several syntaxes you can use for properties, which kind of makes it confusing. Basically, the reason is that with successive versions of C#, the creators are trying to figure out shorter and more efficient syntaxes to just make creating and using properties faster. So don't worry about this for now. Let's just delete that part out. We'll talk about it one day. And let's just use the very most generic get accessor that we can. So what we've done in the past, if we look at, we have an instance of a property here. This is how we did it in the past, right? So you write get and then the open curly brackets, and then inside of that it's just like a function. So you define whatever code you want to happen when this property is accessed. So we'll kind of do that here. We can say get return, and then what are we going to return? Well, we have to return something. If we look back at our other example here, we were returning this other variable that this property is sort of mapped to, or that this property encapsulates. So we can set that up here. Let's make a private string, so we could just make a private string, like private string lowercase d display text, and then use that here. So we can say return display text, like so. And you need a semicolon. All right, so this is one way we can deal with this. I have a couple of thoughts though. One, where are we going to actually initialize this display text? Well, I guess if we're making a unique class for every single interactive, we could just initialize it right here. We could say equals and then whatever we want the display text to be. So if this is just a generic interactive, we can just say, generic interactive object or something like that. And now all of a sudden this property is going to be mapped to that string. But I think we can make this more reusable. So what we can do is use the same code for lots of different objects and just have the objects, what we can do is have the designer actually differentiate and customize the objects in the Unity editor. So rather than do this, we can actually make this thing a serialized field. So we can do something like this. And now the designer can type in whatever they want here, and then we can make that info public to other classes with our property. So that's a nifty way to let the designer still customize this variable in the editor while also exposing that as a property to other classes. So we're just encapsulating the serialized field in our public property. That's kind of a nifty pattern. So now while I'm looking at this, let's go back and think about that other weird syntax we saw for this. Like this is kind of a little robust, I guess I could say. It's a lot of characters to just simply say when somebody tries to access this property, just give them this. So if that's all we want to do, there's sort of a shortcut syntax for that, like I mentioned. So we can go ahead and learn about that really quickly. So just backspace all that, and since all we want this property to do is map to this, we can use this lambda syntax, which is what we saw earlier when we control period quick action to implementing this. And so we want display text to just map to the lowercase d display text. So this syntax is functionally the same as the one we just replaced. It's just shorter and newer. All right. Now that we have added the display text property, if we go back to our looked at interactive display text script, when we try to update this text, now there's actually a thing. Every interactive has a display text. So if you hit period after looked at interactive, we can see there's now a display text, and it only has a get accessor because that's how we defined our interface. All right, so we'll use that. When we update this text, we want to change the text to whatever the looked at interactive's display text is. On the other hand, what if you're not looking at anything? So if you're not looking at anything, we could maybe assume that the looked at interactive is null. And so if that's the case, we want the display text to be hidden. So what we can do is say if looked at interactive is not equal to null, go ahead and do this thing. But what do we want to have happen if it is null? I think, so we'll have an else. We can just simply set the display text dot text to an empty string. So if we just try to print out nothing, it'll effectively be invisible. Now you could try to actually you could lower the alpha on the text object to make it invisible. You could maybe disable various components or the game object itself, but I think this is the most simple approach, so we'll go with this. So we'll just say display text dot text equals, you could just do an empty string like that. This is almost what we might call, if you've heard of magic numbers, this is almost like a magic string, so there's a nicer way to deal with that. Just say string dot empty. And now we have a variable instead of a hand typed in string. Just a little bit nicer. Alright. So this is great, except when do we call update display text? And the other problem would be how do we get a real value in here? I made this variable for the looked at interactive, but it's never initialized, it's never assigned anything, so it's just always going to be null. And then likewise, we need to initialize this as well. We created a variable for the display text, but right now it just has no value. This is null as well, and this would give us problems if we tried to run the game. This one will be easier to initialize if we are sure that we put this script on a game object that actually has a text component on it. So here's my looked at interactive display text game object. It has the script on it, and it also has the text component. Then I can go ahead and initialize that. I can initialize this one with get component. So I'm going to create an awake function. Just real quick, I've been doing this a lot in case you're not familiar. If you start typing something in the Unity API or any kind of IntelliSense autocomplete thing and you want it to actually appear, at this point you could hit tab, you could hit enter, you could click on that, and they're just various keyboard shortcuts for making this complete. Alright, so anyway, awake is what gets called by the Unity engine before anything else happens when the scene loads. So this gives us a chance to initialize the display text variable before this would ever get a chance to get called. So we want to go ahead and say that the display text equals get component display text, or I'm sorry, text. We're going to search the game object that this script is on for a component of the type text. And as long as there is one, this variable will be initialized properly with the display text we want. So now that I have this set up, when I run the game, this variable will actually correspond to this component that's on my script. So I can actually change what it says in code at runtime. How do we figure out what the value of this one should be? Well, this other script here, the detect looked at interactive, this is our script that is in charge of detecting what the player is looking at, and it has this public property for the currently looked at interactive, right? We solved this problem previously by giving this other class that needed to know about that a reference to the other script, and then we could just look at that other script and see what its currently looked at interactive was. But remember, That's coupling. And we want to figure out a way to somehow have this script and this script both know about, they don't need to know about this script. They just only need to know about what the character is currently looking at. So we need to figure out a way for those other scripts to know about this without somehow coupling them all together. And that is where I'm going to introduce our next game programming pattern. And it's called the observer pattern. It's super nifty, and I use it a lot. So game programming patterns, this is the book that we've been using for the class. You scroll down, you can find the web version, which is free. So web, read now, and we're going to check out the observer pattern. And you should give this a read. I'm going to just sort of paraphrase it, but more or less the idea with the observer pattern is you have a certain game object, which would be called the subject, and it will announce out to the world that something has happened. And then you have other game objects that are called observers that are just waiting to see if the subject that they're observing ever announces anything interesting that they care about. And you can do this without having specific references or direct coupling. So in C#, the observer pattern is essentially built into the language. You can see it says right here, C# baked it right into the language with the event keyword. So in C#, when we deal with events, you can just think observer pattern. They have a pretty cool example in the book too. It's about achievements, right? So you can understand the achievement system is just waiting for a specific event to happen, and once that event happens, it is notified. So all these different things are observing particular subjects, just waiting to know when something interesting happened, like this, or all these little examples they have. So it's a good example. Bringing it back to our case, we want all of our other classes to know when the player is looking at a new interactive object. So that's the event that we care about, to use C#'s language. So we're going to create a new event. I guess I would also recommend, if you go to the notes, there is a link to the C# events documentation, which is going to be maybe overcomplicated because it has a lot to do with UI programming and WPF stuff. But in our case, we would maybe recommend looking at Unity's event video, which is nice and concise and specific to our context of Unity. So you look at this, it's only about 6 minutes, so that's pretty cool. All right. So take a minute, pause the video, go look at that if you want a little background on events. Otherwise, we will get straight to it here. Okay, so I'm going to show you what I think is like a pretty simple implementation of events that you can reuse a lot in Unity. So first of all, we have to define the event itself. And the event that we care about is, we can actually make a summary for it right now. We'll say an event raised when the player looks at a different interactive. Okay, so that's what this event is going to be. We're going to raise it, which is that's the special word you do when an event happens. You raise the event whenever this circumstance that this class knows about occurs. So the event needs to be public, and the easy way to deal with this is to also make the event static, which means that the whole entire class shares the same event. That's okay because there's only really going to be one instance of this class anyhow. But if that's just what static means. So actually, if you're not familiar with static, there's actually a good Unity video for that too. I can put that in the notes as well. We can just probably find it. There it is. So I'll add this to the notes too, just in case you want to familiarize yourself or refamiliarize yourself with what static means. All right, anyway, so we have a public static event. So that's the type of this thing we're about to make. It's an event. And the next step is we have to, well, let's just type the name of the event first. That will help sort of explain what it is. So the name of the event will be looked at interactive changed, which means the thing we are looking at is different, right? Hopefully that's self-explanatory. Now, the missing piece of the puzzle to make this not underlined in red is that we have to describe right here what type of method can be called when this event happens. So if you watch the Unity video, they will tell you all about delegates, which are basically a almost like they're like a data type for methods. So you can store functions or methods in just like they're variables. And the idea here is that we're going to store functions that we want to call in this event variable and then call them when this event happens. Well, I find that the syntax for creating delegates is a little heavyweight and frankly confusing. So luckily there is a built-in sort of catch-all generic type in C# that we can use instead of creating our own custom delegate, and that is an action. So I think I have this in the notes actually. Yeah, you can check it out. Here's action. So there's action, which means it has action is for storing functions that have no return type, and function is for storing methods that actually will return some data that you care about. So we're going to use action in this case because we're just going to take in void methods with no return type. So we need to say the type of function that fits into this event is an action. And you're going to see that action is actually underlined in red because it needs a using statement. So if you type in action, then you can just hit Control period, and you can see we just need to add using system. Okay, so now the compiler understands what an action is. So we have the public static event, and the event is going to hold actions, and the event is called looked at interactive changed. And this is a lot of stuff right off the bat, but once we get comfortable with this syntax, it's a very powerful tool. Okay, so we've defined the event. The next question is, when should we raise this event? So when this code, in theory, this class detect looked at interactive, it knows when the looked at interactive has changed. When does that happen? So we could go and look and see, like, is that happening here in this code where we're detecting what we're looking at? Sure. But here's another nifty thing that properties will allow us to do. If this function here is just changing the value of the looked at interactive, we could actually instead use the property, and then we know that whenever you're setting a new value to this property, that's when it's changing. So if we create a property and we want to have an event that gets raised when that property changes, you can just raise the event directly in the property, which is pretty cool. So let's figure out how to do that. First of all, this is no longer going to just fit in one line like this. So we're going to kind of set it up just like any other method that would be larger than one line. and use our curly brackets on new lines just like that. And here we can just put in the body of our sort of set method here. So we still want to do this, but we need to do a little more. We need to figure out if the value is actually changed. So is it being assigned a new value? So the way we can do that, I guess, to make it pretty clear that that's what we care about, is we can just make a bool to represent that. Is it a new value, true or false, yes or no? So bool is interactive changed. Spell it right though. All right. And we're going to say that that equals value is not equal to whatever it currently is, right? So if the new value that's passed in to the property is not equal to the thing that's already stored there, that means this is true. It's changed. However, if the value is equal, then we're going to have a false stored in this variable, right? So now we can do something like this. We can say if is interactive changed, and we can do something in here based on whether or not it's changed. So if it's not changed, if it's the same old thing it's always been, we don't really even need to do this, right? So I suppose it's safe to just move this up here. You can use the hold Alt and the arrow keys to move stuff like that, and then you can use Shift Tab and Tab to move back and forth on your indents. All right, so if it's changed, we need to make sure we update the value of the variable that's tracking this, right? If it's not changed, we don't need to because it's already that. We don't need to re-update it because it's the same thing. And if it's changed and we've done this, we also want to make sure that we raise our event. So the syntax for raising events is also a little special, and you just kind of have to get used to it. So we'll just simply type the name of the event, which is looked at interactive change, and you'll see it has a little lightning bolt icon in IntelliSense here. That's how you know it's an event. So looked at interactive change, and then you can say, so what you could do is just call it exactly like a method, just like that, boom. But this is risky and opens the door to null reference exceptions. If no one cares that this has changed, and no one has told this event about some actions that need to happen in response to this event occurring, then this event will essentially be null, and we're going to try and call something null, and it's going to give us a null reference exception, right? And that's bad. So we need to check whether or not this thing is null first. So you could do something like this. If looked at interactive, we want to use the event. So capital looked at interactive changed is not equal to null. So in other words, there's definitely something there. You can call it like a function like that. But there's actually a better way to do this. So rather than just calling it like a function, what we want to do is actually use this period invoke, which will just raise the event. It will invoke all of the functions that are stored inside of this event. So when this event happens, if it's not null, we will invoke the event, which raises it. Now in the 2018.3 version of Unity, there's actually a nicer, easier way to write this, an easier syntax to do this exact same thing. So what you can do when you want to check if an event is null, rather than write the if statement out like that, you can let's just get rid of this line, right? So we know it's important to double check that this event isn't null before we raise it, before we invoke it. So normally you would have to have that if statement, but if you're on the new version of Unity 2018.3 and above, you can use this special question mark period syntax, which the question mark period syntax essentially just automatically checks if this is null. If this is null, it will not do this. If this is not null, it will do this. And so that is pretty awesome shortcut. It's super handy, and we could call it the null conditional operator as I guess the official word for it. But there is a caveat in Unity, and that is that there's some crazy under the hood stuff happening where Unity is actually has a different definition of what null means than what a typical C# program would consider being null. And as a result, you can't use this for very many things safely in Unity. Like for example, unfortunately, you can't use it to test if a game object is null. At least not right now, maybe one day. So, in other words, the only time you can safely use this in a Unity project is when you're doing something that only has to do with C#. So events are totally a C# thing. So we are allowed to use this nice space-saving syntax for invoking events. So we will use it there and maybe not in other spots. All right. So if the looked at interactive changes, so someone tries to pass a new value in here, we'll go inside of this setter. We're trying to set the value of the looked at interactive. We're going to use this little line of code to test whether or not the thing that's currently stored in the looked at interactive is the same as the value that's being passed in. If it is not the same, so the not equals, if it's not the same as the thing we already have, that means it's changed. If it's changed, we need to update the value, and we need to announce to the world, yep, the looked at interactive has changed. And that's what this is doing. We're raising this event. Meanwhile, we can have other scripts care whether or not that event has happened. So we can go back first, I suppose, and take a look at our text. So here's the display text script. We need to care that they're looking at a new thing, right? So what I'm going to do, we need to write an event handler for that. And we need to subscribe and unsubscribe from the event. So we can go ahead and write our event handler first of all. So this will be the function that we want to have called whenever the event is raised. So we can actually, well, yeah, we can make a summary for it. I guess it won't let me until I have a thing to summarize. So private void on looked at interactive changed. This will be the function that we want to get called whenever that event is raised. So inside of this, we want to define how we want this particular script to react to the looked at interactive changing. So one thing I know we need to do is we need to call update display text. So now we know exactly when we want to update that display text. So we don't need to do it in update every single frame. We only need to do it when this thing changes, right? A quick note on naming event handlers and events themselves. It's a good idea to name your events as like past tense things that have happened, or maybe things that are about to happen. So the event here should be called, let's see here, where's the event? There we go. So the event is called looked at interactive changed. This is a thing that just happened, right? The event handler should be named on whatever the name of that event was. So on that event do this stuff. It's just a good naming convention to get in the habit of following. So what you don't want to do is name your events themselves on so-and-so. Name the event handlers on so-and-so. Name the events themselves after the actual thing that is happening or just happened or is about to happen. All right, anyway, so we want to update the display text, but we also really need to update the value of this. We need this variable to be filled in based on whatever the player is actually looking at. So we need to actually add a little bit more info to our event. This class that raises the event, it knows exactly what the player is looking at. It just needs to broadcast that in addition to letting everyone know that the looked at interactive changed. It also needs to provide, hey, here's actually the thing that changed also, just so you have a specific reference to it. So the way to do that, just using the action syntax here, or the action delegate, that means it's a void function that fits into this event with no parameters. But what we need to do is actually add a parameter. We need to say that in addition to just telling everyone that this happened, we're going to also provide you with a specific object that's going to, in this case, be the thing that we're now looking at. So you can see that uppercase T here means it's a generic type. You could make this whatever type you want. We've seen the syntax before with getComponent, right? So remember, you can type in whatever type you're looking for in getComponent. Well, same thing with action. We can use whatever type we care about as a parameter here. And the type we care about is an interactive, right? So now, in addition to telling everyone that this thing has happened, we're also going to pass along an interactive. And in this case, the interactive that we pass is actually going to be the new looked at interactive, so that everybody who cares actually has a direct reference to the new object that we're looking at. So because we said that we need to include a parameter in this, when we raise the event, we actually have to supply that parameter. So we are going to go ahead and pass along the looked at interactive, right? It's going to be pretty important to do this after you've updated the value. If you were to update the value after sending it out to everyone, everyone's going to get the old one. We want to make sure that they get the new one. So we pass in a new value, we go into the setter, see if it's actually a new value. If it is a new value, we store it into the encapsulated field here, and then we send out that info to everyone by invoking our event and passing that new looked at interactive as a parameter in our event. So because we are passing a parameter, that means all of our event handlers also need to have that parameter. So we need to define a parameter into this function if we want this function to work as an event handler for that event. Maybe I can make that a lot more obvious. So before we go ahead and add the parameter there, let's go ahead and deal with subscribing and unsubscribing to the event. So the easiest, oops, I didn't mean to delete my close curly bracket there. All right, the easiest way in Unity, or one of the most common ways to subscribe and unsubscribe from static events like that is to use the onEnable and onDisable Unity functions. So these get called automatically by the game engine whenever this game object is enabled or disabled. And what that means, essentially, if you were to uncheck this, that's disabling it, that's enabling it. This enable gets called essentially whenever the object first starts also, so it's similar to start in that regard, but it can also be called more than once. Every time this happens to get enabled or disabled, it will continuously call these functions, right? You can see these are more or less subscribing to, these are more or less reacting to events in the engine itself, right? So you see the on enable. All right, so what we're going to do is when the object is enabled, we're going to subscribe to our event. The way to do that is you type the name of the class, which is detect looked at interactive. That's just the name of the class. We don't need an instance of the class. We just need to know the name of the class. Then period, name of the event. So looked at interactive changed. I'm going to hit tab. All right, so now we have the event going. The reason we can access this without a reference to the class is because we made it static. So remember, since this event is static, it belongs to the entire class detect looked at interactive, so you don't need a reference. You just need to know the name of the class. So the name of the class dot the name of the event, and here's where we're going to subscribe. We hit plus equals, so we're going to add something to happen to this event. We're going to add an event handler to this event so that when this event is raised, our event handler actually will get called. So the thing we wanted to be our event handler is the on looked at interactive changed, just like that. But you'll notice it's not going to work. The reason it's not working is because the event handler we're trying to pass does not match the quote-unquote delegate that this event uses, right? So if we go back and look at our event, it needs to have the only things that will fit into this event are things that match this, which means it has to be a void function that takes in an iInteractive parameter, right? Because when this event gets invoked, it's going to broadcast to everyone that it happened, as well as pass along the currently looked at interactive. So our event handler right here, right now, it doesn't have a parameter for the currently looked at interactive. So we should add that in. I guess what I'm going to call it, so it's of the type iInteractive. It has to be because that's what we've said here. Our event will only work with functions that have an iInteractive parameter. All right. And the name of this is going to be, to make it clear what this is the new looked at interactive, right? So this is the new one, right? So when this event gets raised, it will call this function and pass in whatever the new looked at interactive is. So now that we know what the new looked at interactive is, we can set this variable that we've had all along, this field, to have that value. So we can say looked at interactive equals new looked at interactive. And you can see down here, it's no longer underlined in red because now all of a sudden the thing we're trying to use as our event handler actually has the correct parameter that it needs to fit into that event. All right. So when the event happens, we've subscribed to the event as soon as the class starts. So that way, whenever that event happens, it knows to call this function, which will update this class's understanding of what the currently looked at interactive is and update the display text based on that. So this is what we call subscribing to the event. That's what the plus equals means. We're adding this handler to the event. But there's also this concept of unsubscribing. And the reason you have to unsubscribe is that if this game object were to go away, if this class were to go away, and then the event got raised, so we've already subscribed to the event, then our class gets destroyed, and then the event actually happens. So we raise the event. When we raise the event, it's going to try to call that function. It's going to call the function of all the event handlers that have been added to it. Well, we added this one to it, so it's going to try to call a function from this class, but this class is gone. So that's going to cause essentially another null reference exception and screw up our game. So we actually have to make sure that when this class goes away, we have to go ahead and tell our event, hey, we don't care anymore, we're gone, so that you don't try to access our class when it doesn't actually exist anymore. So the syntax for unsubscribing is super easy. It's essentially exactly the same as subscribing, except instead of plus equal, it's minus equal. So when our class goes away, we just go ahead and tell the event, don't worry about this anymore, we're done. Alright, so let's add a couple comments here to help things out. First of all, I wanted to put a summary on this to explain what it was. So now that I have a function, it makes it easier to use the summary hotkey, the 3 forward slashes. So what is this thing? This is the event handler for detect looked at interactive, looked at interactive changed. There we go. And what is this? So we see this new little bit here. That's because since this function has a parameter, we can have an opportunity to explain what that parameter is. So the parameter is just a reference to the new interactive the player is looking at. Right? So it should be very obvious what this is doing and how it works. So the neat thing about summary tabs, or tags rather, is that if you mouse over this, or if you're trying to call this function somewhere else, it's actually creating the documentation for this function. So you can see it's actually explaining it right there just by the tooltip. So it's kind of more useful, I suppose, in public cases, but you can see if some other class was trying to look and see what this did, it would actually give us this helpful info right there. So the summary is sort of like a more useful comment. It takes care of whatever a comment would do, but it also does this extra thing of creating documentation for your class and your methods. Okay, so I want to also clarify that this is where we are unsubscribing and subscribing to the event. So the way I'm going to do that is actually with a region. If you go to our style conventions, there's a part about regions. Here we go. So wrap blocks of related members and regions. So you can see this one, it says create a region for event stuff. I'm going to actually make a region right here to sort of label this chunk of code as subscribing and unsubscribing from the event. So the way you do that is you type in region, so it's like hashtag # region, and then you type in the name of the region. So we're going to say event subscription, well, we can how about like this, right? So this is just labeling this part of our code so that we understand what it's for and when you need to look at it and when you don't need to look at it. So then you have to make sure you use the end region tag there. And now what I can do is I can just minimize or collapse that whole chunk, and it just makes it a little bit more manageable. So it's like another more helpful version or a souped up comment, right? It's commenting this whole section and saying if you don't care about that, feel free to just collapse it and don't look at it, right? So we can collapse in Visual Studio all of our methods and summaries also, and really basically make this all only allow people to only look at what they care about looking at and understand what is happening in each region. So it's just a good practice to get in the habit of. Okay, so we've basically taken care of having our display text subscribe to that event and react to it. We need to do the same thing with this class. Remember, our goal is to get rid of the direct reference we have to that class. So we'll go ahead and we can actually kill this now. We don't need this because we're going to use the event and the observer pattern instead. So we can get rid of that. But what I'm going to do is sort of follow the similar pattern I had in the other class. So I'm just going to make a private field for the interactive that represents what the player is currently looking at, right? And then I'm going to write an event handler for the looked at interactive changed event that will fill in this with a value whenever we're looking at a new thing. So we can go down here and do that. So private void on looked at interactive changed. I didn't mean to capitalize the T here. And really it's going to be pretty similar. You could probably have just copied and pasted this part if you wanted. Anyway, so it needs to have a parameter for the interactive new looked at interactive. All right. And what's going to happen in this? Well, for now, I know that we need to supply this field with the actual real value. So we will say that the looked at interactive equals new looked at interactive. There we go. And since we sort of refactored how this is working, we have to kind of update this. We're not going to use the reference to the other class anymore. We're going to use our own little field that we have to keep track of it. So we're just going to say looked at interactive dot interact with. So this thing should have a value because of the event, and we can just say interact with the thing. We have to make sure we remember to do subscription and unsubscription. Oh, and we got to update this too. Again, we don't want to use that reference to the other class. We just want to use our new little field that we made right there. Okay, so let's go ahead and make a region for subscription and unsubscription again, just like we did before. Because really you don't need to ever care about this part of this script. It's just pretty cut and dry what it's doing. And I'm actually going to literally copy this code from the display text because it's going to be identical. So I'm just going to copy the on enable, which has the event subscription, and the on disable, which has the unsubscription. And as long as we named our event handlers exactly the same, it should just be a simple copy and paste. Here we go. And let's just double check I actually typed everything accurately. Looks like I did. So we've got our event. I'm going to capitalize this just to be super formal. Okay, so here's our subscription and unsubscription. Here's our event handler. We can actually put a summary here too, and I think probably the same summary is appropriate, although I see I have a typo here. So before I copy and paste this, let's actually make sure there's no typos. Let's go back over here and paste this in. Okay, looking good. Okay, so before we test all this out, there's one more thing I want to do quickly. Take a peek at your detect looked at interactive script here. I'm going to go ahead and get rid of some white space, but I want to address this block of code. So when I just put code straight and fixed update, it's kind of unclear what it's doing. I would rather put this code in its own method and name the method. That way the code has a name that goes with it and it's a little more clear like what it's doing. So really we need to decide what is this code doing. It's actually simply updating the looked at interactive, and I'm spotting a bug because, well, we'll talk about that in a second. So let's just make a new, what we'll do is we'll select all this stuff and we'll hit control period to refactor it, or as Visual Studio calls it, extract method. So we're going to extract all that code into its own named method. So we hit enter to do that, and we're going to name this method. What's it really doing? It's basically just updating looked at interactive. We're doing all this and updating the looked at interactive, or we could say that we're getting the looked at interactive. So let's say that we'll say get looked at interactive. All right, and then you hit enter and it'll sort of finish this extract method process. I want to change this a little bit. I want this function, instead of being void, I want it to actually get a new looked at interactive. So we want to return an I interactive, right? And instead of doing this right here, I want to return the looked at interactive. So you can see, since we said this thing returns an I interactive, it's going to give us a compile error until we actually make it return something. So what I'm going to do, I'll just add this to the end right now, and then we'll go back and think more about it. But I'm just going to say return, I'm going to return this, right? Because this is the new thing. If you just remember how this function works, which I know it's been a while, it's doing the raycast. If the raycast hits something, in other words, if the object was detected, we're going to see what the thing it hit was. If it was an I interactive, we store that I interactive in this variable, this local variable interactive that we made, and then we can just return that here. So that way when you call this function, it's actually going to give us back a reference to the new thing the player's looking at, if there is one. It could be null, right? If we're not looking at anything, this would actually be null. But I think it's actually okay for that to be null, because if we think about how we were dealing with our text, the text actually does something different if the currently looked at interactive is null. So we need to go ahead and say we don't want this to just always remember the last looked at interactive. We want it to be, are you currently looking at an I interactive? If so, what is it? If not, just let it be null. That's the only, that's how our text will work correctly. So what I want to do is, let's go ahead and get rid of, here's another interesting thing. Here we're directly updating the value of this field that's encapsulated by this property. If we do that, we're never going to go inside of this set accessor that we made. And the set accessor is really what's driving everything, because this is what's actually saying, hey, is there a new thing? If so, broadcast the event, raise the event. So if we skip this, nothing is going to work. So we don't want to directly change this. We want to actually just change the property. And so rather than even do any of that here, what I'm going to do, let's delete this. So now at this point, all this is doing is getting the looked at interactive, if there is one, and then returning it. So right now we're returning it into just nothing. We're not using the value, so we need to use it. So instead we're going to say looked at interactive. It's very important that you use the capital L property equals get looked at interactive, right? So now what happens is every fixed update, we're going to see if we're either hitting a thing or not hitting a thing, and we're going to store whatever we're hitting or null into this property, which will then go inside of our setter, and if the thing that's stored into the property is new, we will update the value and we will broadcast the event, which will really make everything else work. So let's go ahead and add a couple summaries to clarify this. So we're going to say, what is this function doing? It raycasts forward from the camera to look for eye interactives. And then you'll notice, since this is actually not void, it has a return type, we have a little spot to provide information about what it's actually returning. So what is it returning? It's returning the first eye interactive detected, so whatever the raycast hits, or it's returning null if none are found. So if there's no eye interactives, it's just going to return null, which means we'll store null in the property, which means when we go broadcast out what the currently looked at thing is, if it's null, we will make our text empty. So that's all good. We want that. Okay, hopefully I'm not forgetting anything. This was a lot of changes. Let's go ahead and save everything. And we can try running the game and see what happens. And if it works, awesome. If not, we will quickly do some debugging and figure out what we missed, because there has been a lot. Alright, so it compiled. That's a good step. Let's go ahead and run it and see what happens. So right away, I can see that the text is not updating. That is not good. And I can also see that if I walk up to an interactive object and look at it, the text goes away. So that's curious too. So two things to let's stop the game, and I actually think I have a pretty good hunch about both of them. So first of all, why is the text not updating right off the bat? Well, it's because we never told it to. So let's go into our display text. See, here's part of what's good about, separation of concerns. I have a problem with the display text. I just want to go right into that display text class, and I know that's where I can fix that problem. Everything is very self-contained now. Anyway, I have this cool update display text function, and I think it works, but I don't call it until the looked at interactive changes, right? That's when this happens. When the on looked at interactive changed, that's when we do this. So really, we should probably do it in awake as soon as we want to make sure you do it after you initialize the display text, or it won't work right. So initialize your display text and then update it. So let's save that and test the first bug. If I go back to Unity, oops, here we go. Let's go ahead and run it, and I would expect the text to just instantly go away. Boom, there we go. So that's cool. Now we have to see, well, wait a minute, I'm looking at this and there's no text. Well, the reason for that is if you take a look at this cube, which is our interactive object, right? I can go back to the scene view, get out of 2D mode, double click it. Here's the old cube, right? So if we look at this thing, we look at the scripts on it. It has an interactive object script, but check out the display text. Nothing. So I could type something in there, but I actually want to test something else out real quick. I feel like it is an oversight to leave this. I think there should be default text, is what I'm trying to say. So let's go back to our code, and find the interactive object script. And so here's the serialized field for the display text. Let's give it a default value. Now, I'm just going to use a quick example of another new thing you can do with 2018.3, Unity 2018.3 and above. You can use the name of function. So I could just type something in here like, you know, interactive object, right? But this is a sort of a magic string, right? It's just something I typed. It's vulnerable to typos, right? What if I did a typo there, etc.? There's actually a nifty way to, if I just want the display text to be the name of this class, there's a nifty way to get that string without typing it in by hand. So name of interactive object. The name of feature of C# will give us the name of this class as a string. So now there's no way I can actually type it wrong. And so the default display text is just going to be the name of this class, which is pretty cool, I think. I'm going to save it. And actually, if you go back, you're going to notice that this isn't going to update, because the way Unity works, if you change the default value of a serialized field, that will only change new instances of that script. So since this one was already here, it's not going to overwrite what I had. That's because what if I had something useful there? I wouldn't want to lose my useful stuff that I spent time configuring just because someone changed the default. The default will only affect new ones. So if I were to put a new instance of that script on here, interactive object, you can see it comes in with the default text. Well, I don't want two of them. So let's instead, if we want to revert this to its default, there's actually, if you right click on it or you choose the little gear here, there's a reset. And if you click reset, it will reinitialize it with all the defaults. And since the default is interactive object, which is the name of this, right? Remember, name of, there it is, pretty cool. There, now we have a default display text. So let's run the game now and see if when I look at the cube it says the display text. Boom. Alright, so we are really getting somewhere now. Our text is updating. None of our code is coupled. We are using the observer pattern. I'm just going to leave you with one last reflection on how we're using the observer pattern. Basically, the detect looked at interactive script, this is our subject. So in the context of that observer reading assignment, wherever that went, here it is. When you read this and it talks about subjects, this script is the subject. And then what it's doing is it's announcing to the world when something interesting has happened. What is that interesting thing? That's our C# event here. It's announcing when the looked at interactive has changed. So this is our subject. Meanwhile, we have two observers. The interact with looked at is an observer. It's observing the subject. So when the subject tells us something interesting, this class cares about it and is going to react to it because it has subscribed to that event. The observer subscribes to the subject. We have one more observer. This guy right here is also subscribing to the event. So this is another observer subscribing to and observing the subject here. All right. So that's a lot to digest. If you have questions, definitely let me know. Otherwise, I'm going to call this video done and we can start thinking about what's next.